Today we're going to take a look at solving systems of equations by using the substitution method. So the way the substitution method works is just you have an equation, let's just say like 2x plus y equals 6. And we're given a value of x equal to 3. What substitution is taking this x value of 3 and substituting it in for x and replacing x with that value to get the value for y. So that would be 2 times 3 plus y equal to 6. And then you would just solve for y. So in this example that I just made up, 2 times 3 is 6 plus y equal to 6. And then you subtract 6 from both sides and you get y is equal to 0. So that's how substitution works. That's the process of substitution. You're replacing x or y with some value, or in this case, we're going to be replacing it with expressions or different types of scenarios here. So let's take a look at the first one, solving with substitution. We have the equation x plus y equals 5 and x equals 4y. Here's how I like to go about doing the substitution method, at least until you get a strong understanding of what we're doing. I like to have this like left to right approach, or right to left, however you want to think about it, where I want to substitute in a value or variable by itself. So I have in the first equation x plus y equals 5. I don't have y equals something or x equals something. So since I don't have just an easy x equals or y equals, let's look at the second equation. In the second equation, I have x equals 4y. So there I have one x on one side of the equal sign, and then I have 4y on the other. So that means I can substitute out the x in this equation for what x is equal to. So I'm going to take 4y, and I'm going to substitute it into the equation over here. So x equals 4y, so I'm replacing x with 4y. So 4y plus y equal to 5. And then from here, I'm going to solve for y. I'm going to combine like terms. So 4y plus 1y is 5y equal to 5. And then I'm going to divide by 5. So I get y is equal to 1. So after I do that substitution of x being equal to 4y, because I'm told x equals 4y, just like up here, I was told x is equal to 3. So when x is equal to 3, I replace x over here. Same concept, but x isn't equal to just a number, it's equal to 4 times y. Let me go through and solve. Now here, I have my y value. So what I want to do now is I want to take that y value, and I want to substitute it back into this equation. So I'll have x equals 4 times 1. So x equals 4 times 1 is 4. So now I have an x, I have a y, I have an ordered pair of 4, 1. Because this is the ordered pair. That will make the system true. Just like when you looked at graphing, you have two equations, they cross paths at a certain point, that's the ordered pair. So that's what happens here with substitution. We're just not graphing. We're just doing the substitution here. Let's take a look at another one. On this next system, we have 7x minus 8y equals 3 and y equals x minus 1. So in the first equation, 7x minus 8y equal to 3, and the second equation, y equals x minus 1. In the first equation, I don't have a variable by itself. I just have 7x minus 8y. I don't have like a y equals or x equals statement. So I look to the next equation. Here I have y equals x minus 1. So this is my substitution. And this is why I like to, let me go back to this problem while I describe this. This is why I like this horizontal approach, where I go from here to here, get my answer, and then I go right back up to my original problem. It's like a recycling symbol. It's a circular process. It goes here to here, and then we go right back up. So it's just a nice visual for people to see that pattern. And then you can know where you're substituting in and how we get those solutions. So here I'm going to take x minus 1 and replace y with x minus 1 because y is equal to x minus 1. So I'm taking out y and replacing with x minus 1. So let me write this out, and I'm going to show a common error here. So 7x minus 8, and this is times x minus 1 equal to 3. And it's multiplication because it's minus 8 times y. So since it's minus 8 times y, it's going to be negative 8 times x minus 1. Here's a common error. I'm going to erase this. But 7x minus 8y times x minus 1. You see that? See how I wrote that? I didn't replace y with x minus 1. I just wrote 8y times x minus 1. That's a common mistake, but you got to understand that this is substitution. So we're subbing out the y and replacing it with x minus 1. So I don't have a y anymore. Once I replace y with x minus 1, that's changing what y is equal to. Y is equal to x minus 1, so I'm changing what it's saying. So I'm not writing down y, I'm writing down x minus 1. Think of it like in basketball. You have a point guard on the court. When you perform a substitution, the point guard comes off and a new point guard comes on. Now, I know you could technically have more than one point guard on the court, but I'm just saying there's a one-to-one substitution there. I'm subbing in this player, so you are now in the game, and this other player is coming out. You're not both staying in the game and no one comes off. Someone has to come off that court. Now we're going to solve. So I'm going to distribute -8. See that? -8, because it's 7x minus 8. So we have to do -8 times x, -8 times -1. Another huge potential mistake there is not distributing negative along with that. Because if this was 7x plus 8 times x minus 1, in this situation, this is 8 times x and 8 times -1, that would just be fine because it's plus 8 times x minus 1. But here, it's negative. So we have to distribute the negative there. So let's continue on. 7x minus 8x plus 8 equal to 3. Combine like terms. 7x minus 8x is -1x plus 8 equal to 3. I'm going to subtract 8 from both sides. This is just solving equations. -x equals 3 minus 8 is -5. And then I have to divide by -1. So x equals +5. -5 divided by -1 is -5. Or I'm sorry, +5. So we have +5. Now I'm going to take that x value and substitute it right back into there. So I like that recycling process. It goes in here, comes back out, go there. So y equals the x value of 5 minus 1. And we get a y value of 4. So my ordered pair would be 5, 4. If I were to graph these two equations, they would cross paths at the ordered pair of 5, 4. Let's take a look at another one. So in this system, we have 2y equals 39 minus 3x. And x equals 5y minus 4. So similar to the last one, we have x equal to something. So I'm replacing x with what that is equal to. So I'm going to go ahead and substitute 5y minus 4 in here and replace x with 5y minus 4. So I'm going to have 2y equals 39 minus 3 times 5y minus 4. Same thing we talked about in the last problem. I have minus 3 times 5y minus 4, so I'm going to distribute -3. So this is going to be -3 times 5, -3 times -4. If you're going to make a mistake here, it's probably going to come right there. It's so easy to just blow right by that and just distribute 3 without thinking about, wait, it's -3 times whatever that x value is. So you have to do -3 times 5, -3 times -4. So 2y equals 39 minus 15y plus 12. I'm going to do 2 steps in one here. I'm going to combine these like terms, 39 and 12. And then I'm also going to add 15y to both sides because I want to get the y's together. So I'm going to do a 2 for 1 there and just combine the like terms and also add over the 15. So I'm going to get 17y equals 39 plus 12 is 51. Divide by 17, because we got to get y by itself. So that's going to be, I think, 3. Yeah, 3. Y equals 3. So I get a y value of 3. I'm going to substitute it into here. X equals 5 times the y value of 3 minus 4. X equals 15 minus 4. X equals 11. So I get the ordered pair 11, 3. So these last couple problems that we just did, we had an easier scenario because we had a variable by itself. So here I had x equals to 5y minus 4. So that was a pretty straightforward substitution. I'm going to replace x with 5y minus 4. And then on this one, I had x equal to 4y. So I'm going to replace x with 4y. This one, I had y is equal to x minus 1. So I'm replacing x minus 1 and replacing out the y. But if you take a look at number 4, I don't have that luxury. I have 8x plus 2y equal to 7. And then I have negative 4x equal to y plus 8. So in this scenario, In the first equation, I don't have a variable by itself. In this equation, I don't have a variable by itself. So I have to create a scenario where I have a variable by itself. So I have to look through my options here and pick a logical choice. Like if I look at this first equation and I try to get a variable by itself, like for example, like 8x, if I try to get this x by itself, try to work through it a little bit mentally and just see like what ends up happening, because what I'm going to have to do is I'm going to have to subtract 2y. So I'm going to have 7 minus 2y, and then I'm going to have to divide by 8. I'm going to end up with fractions because I'll have 7 over 8, 2 over 8. Like I'll have to end up with that weird fraction. So probably not want to go that route. Same thing with the y here. At some point, I'm going to have to divide by 2. This is 7 divided by 2. That's not going to be a nice number. So this is probably out using this equation. So let's look at this equation. I have negative 4x equals y plus 8. If I try to get the x by itself, I divide by negative 4. So y is going to be divided by negative 4. 8 is going to be divided by negative 4. Not the worst thing that could happen, to be honest, because y divided by 4 and then substitute into here, like that would actually work out okay, but not the most straightforward route. But if you look at the y, look at the coefficient on the y. The coefficient on the y is 1. So since I have a positive 1y, I'm just going to get rid of the 8. So that means I'm left with y equals negative 4x minus 8. That's a lot easier than dealing with dividing by some number, than dealing with a fraction. I'm not saying the fraction is like overly difficult, but why do that when you could just solve for this positive 1y variable and just get rid of the plus 8? So now we have a variable by itself. I have y equals negative 4x minus 8. And then from here, it's the same exact process. So I'm going to substitute out y, replace it with negative 4x minus 8. So 8x plus 2 times negative 4x minus 8 equal to 7. So I'll have 8x. 2 times negative 4 is negative 8x. 2 times negative 8 is negative 16 equals 7. So now look what happens. 8x minus 8x. 8x minus 8x is 0. So this goes to 0. Minus 16 equals 7. So 0 minus 16 is negative 16 equal to 7. That's a false statement. Negative 16 does not equal 7. So since that's a false statement, I'd have to make the conclusion that we have no solution. There's nothing else I could do because those variables dropped out. 8x minus 8x is 0. So that just drops out. Let me just double check, make sure I didn't write something down wrong when I was transferring it. Minus 8, yeah. So that looks all checks out. 2 times negative 4 is negative 8. 2 times negative 8 is negative 16. Yeah. So no solution there. And then sometimes that'll happen. Just like how we looked at with graphing. If you think about what does this look like graphing-wise, those are just going to be two parallel lines. They're going to look like something, but they're going to be two parallel lines where we have no solution. All right, one more problem. So solving this system, we have x equals 3/4 y minus 1, 16x minus 11y equals negative 14. So I have the x already by itself. I have x equals 3/4 y minus 1, and then I have 16x minus 11y equals negative 14. X is by itself. That's going to be the straightforward substitution there. So let's do 16 times 3 over 4y minus 1 minus 11y equals negative 14. A lot of moving parts here. We're going to do 16 times 3/4, 16 times negative 1, then we have that minus 11y equals negative 14. So 16 times 3/4, let's do this right here. 16 times 3/4 is going to end up being 4 times 3, because 16 over 4 is 4. So then 4 times 3 is 12. So I'll get 12y there, minus 16 times negative 1 is negative 16, minus 11y equals negative 14. Combine like terms, 12y minus 11y is 1y minus 16 equals negative 14. And then add 16. So we get y equals negative 14 plus 16 is 2. So I have my y value of 2. Now I'm going to go ahead and substitute it into here. So that will be x equals 3 over 4 times 2 minus 1. And unfortunately, we do have to deal with some messy fractions here because 2 over 4 is going to simplify down to 1/2. So x equals 3/2 minus 1. So that would just be over 2. So 3 over 2 minus 2 over 2 is going to be 1/2. So 3/2 minus 1 is 1/2. So x equals 1/2, giving us the ordered pair 1/2, 2. And there it is. There is our solution on that one. So the key here is looking at this fraction when we do that substitution. This actually worked out nicely where we didn't have to deal with a bunch of fractions, but then in the back end of it, we did have to deal with that fraction. But nothing too complicated there. Nothing that isn't manageable. But I want to go back for a quick second, back to this no solution problem, and just talk about another scenario. Let's pretend that we got 7 equal to 7. So we went through and solved, we just got 7 equal to 7. In this scenario where 7 equals 7, we get a true statement, and this could take a lot of different forms, but if we get a true statement, that means that you have infinite solutions. And if you think back to graphing, infinite solutions means that you have 2 lines that are exactly the same. You just have the exact same line stacked on top of one another, where any single point on that line is going to be a solution. So there's infinite solutions for that one. All right, hope this helps.